Hey everyone, today we're going to make a video on fans and how to PWM them from the Holley ECU. So what we have here is these are 2017 Chevy Silverado brushless fans. We're putting these things in my car. They are, normally they come with a giant plastic shroud, but Matt and Brandon at Performance Fab made these aluminum shrouds, like the mounts and whatnot for them. Came out awesome. They did a killer job. But what we're going to do today is show you how to wire them up, how to program them in the Holley, and how to make it work. So this will work with any PWM fan. The Chevy Volts, the Dodge Hellcats, dual fans, there's quite a few of them out there. So if you see a fan motor like this, right, and it's 3 wires, this will work, okay? So you got power, ground coming into them, and then you've got a PWM negative signal coming into this fan. So some of the fans require a PWM positive, some of them PWM negative, but these are a negative, okay? So what we did was we used the factory connector, which is an Apex GT 2.8, and ran them over here to a little dual 70 amp relay block from Leash, right? So disregard the fuses, it doesn't really matter, they don't have to be this high. We'll show you what they draw with an amp clamp, but we've already tested these things and they pull right at like 25 amp at full tilt on 16 volt. So we ran the power wires here, so these things can actually be wired where they've got power all the time. It's actually the way the factory wires them, and then they just get sent the PWM signal from the ECU. I decided kind of against that. I don't like having power on something all the time, so we're going to send signals from the ECU to turn this on, right? So these are going to turn on so that we actually supply 12 volt, but that's not actually going to turn the fan on. Then we're going to send a separate PWM signal from here to pulse the fan. So you could just, if you wanted to and not use up a bunch of outputs in your ECU, you could just, with switched ignition, turn these relays on. And if you don't know how these work, they need a ground signal on one side and then a 12 volt on the other, and it turns the relays on, and then all the load comes from this terminal here. So when this gets put in the car, you'll understand that a little bit better. And then we ran the grounds up here to, there's a chassis tab right here. So we're gonna grab chassis ground right here. So this is going to go in the car. We got a little bit of work to do, and then we'll kind of we'll go over the rest of this. Side note, just because it came out great, we mounted a Rife sensor block right to the side of it. We've got coolant temp, we've got coolant pressure, and then air temp plugs in right here, and then our dome pressure actually plugs in right here. So we'll go over that once it's in there, and then we're using a Davies Craig pump that literally screws right onto the end of this thing. We just gotta make some hoses and mount it in the car and whatnot, so we'll be back. All right, so here's the fans that we decided to use. Again, Chevy Silverado, like 2017, 1500. This is what they look like from like when you buy them from Advanced Auto or Amazon or whatever. It's enormous, the shroud's huge. Doesn't fit anything. Yeah, I mean, it might fit in a pickup truck, but not in a Fox body. So they flow a tremendous amount of air. So that was the reason for it, and we can pulse them up and down and whatnot. So after a good bit of fabrication, this turned into over here. So the radiator and fans are in the car, and it's tight, as you can tell. This thing's packed. So we got the shroud, and then these mounts for the fans bolt onto the shroud, and then we're wired up down here. So a little bit of a mess down here because we got the plug-in for the oil heater, headlights, fan, or a horn. But anyway, it's actually easy to remove. Pop this bolt and these 2 connectors right under here, and this right here, and you can pull out this whole water pump and radiator and fan combo all together. So it takes a little bit of effort, but all this comes off with it, so not too bad. But anyway, so what this is we've got a dual Leash 70 amp relay here, and we are sending 12 volt to it on the trigger wires here from the smart wire, telling it right here, telling it to give this 12 volt power, right, to turn the relays on. So the way these fans work is that they get, you give them ground and then you give them 12 volt and they don't turn on. They don't just turn on like a normal fan. You have to give them a duty cycle from a PWM negative. So I decided that the best thing to do, for, in my opinion, was to give it 12 volt right before you wanted the fan to actually turn on. So instead of just having 12 volt hot all the time, what we're doing is we're grabbing 12 volt out of the, out of the car from the smart wire and turning it on at a desired temperature, right? So once it's at the desired temperature, you still have to give it a PWM signal. So this is literally just giving the fans power. So, and then they're fused and whatnot. And these fuses are way too big, but we have an amp clamp on it. They draw, at full tilt, they draw right around 21 amp a piece. So, fans are wired up, and then we have a PWM negative signal sent to it. So, and if you haven't followed along with this car at all, again, this is an educational video teaching you how to use PWM fans, but if you haven't followed along with this car at all, that's about the biggest damn radiator you can fit into a Fox body. So, Matt at Performance Fab just fit that radiator on it. We went a little bit wider. That way we could fit the dual 15 3/4 inch fans. So if you're looking at doing those Silverado fans, they are 15 3/4 wide piece. So now, do the math, you need a pretty big radiator. So then there's our Rife sensor block. Again, this is all tied in. We made this so that you can remove the whole module itself. Davies Craig water pump. It splits out and it goes, look at that, we're leaking. We just put water in it, so it's got a little bit of a leak. It's all right, we'll find that. So anyway, we are going to kick these on and play with the PWM. So I'm gonna switch over to, no, we won't switch over to screen capture. So what I'm gonna do is get on the computer that's hooked up to the car, and we're going to show you how the PWM works, sent over to the fans. So, is that visible? Yes, no? Yeah. Okay, all right, so what we have here, I got fan PWM 1 and PWM 2, because we're gonna control each fan independently, right? It's a PWM negative, right? So pulse width modulated, go to configure. I have no input triggers because of testing, so when this is done and this video is over, this will be set up a little bit different for when we're driving down the road, so it's all automated. But for this, what I want to do is be able to show you what it does. So go to PWM setup. I just used RPM versus coolant temp, right? So it's just auto scaled to whatever. But the way this is going to work is this first cell here are probably going to be, 40 degrees. And then this cell here is probably going to be 250. And if we ever get up there, there's a problem. We can left click, highlight, and fill row values. So if you notice this little orange bubble here, can you see that in there? You can see that, okay. So that little orange bubble is indicating where we're at, right? So it's like right around 65-ish degrees, 67 degrees. So it's landing right here and the car is not running, we're at 0 RPM. So the setup for these fans is the type is fixed and the frequency is 100. We tried a whole bunch of different frequencies, and it seems as if this is operating range is somewhere in between 100 and 120 hertz. For the GM stuff, it seems like you just set it at 100 hertz and it works. Duty cycle is our table units, right? So 100% duty cycle would be on, but in this scenario, and this is why this is important, 100% does not actually turn the fan on 100%. So GM's got an operating window. If you notice, I'm at 10% duty cycle right now, down here, these cells down here, right? And the fan's not running. I'm gonna bump it up to 15%, the fan just kicked on. All right, so, yeah. So we look, the fan's on at 15% duty cycle, right? And it's pulling right at, it's upside down, so bear with us here, but it's pulling right at 1.3 amps at 15% duty cycle. So Watch what happens. I'll speak and you'll see the fan pick up in speed here. So if we go from 15% to 25%, I'm changing the table to 25%. The fan's picking up speed. All right. So as we pick up more speed, we're moving more air, and the amperage draw has gone up to
1.8.
Okay, so barely moved at all. So let's go to 50% duty cycle. So that's 50% duty cycle right there. It's slowly ramping up. So as it's moving up to 50% duty cycle, we're drawing 4.5 amp. I'm gonna run it up to, we're gonna run this thing up from 50%, and you'll be able to just hear it as it draws more. We're gonna run up to 75%. They hear the fan ramping up, right? And then as we go, let's go to 90% duty cycle, right? So now that fan is pinned wide open. So you're probably gonna say, well, why don't you just put it at 100? Well, watch what happens, right? You hear the fans cranking, moving a ton of air. Boom, off. So there's a band, okay? So the way this works is that there's a low and a high cutoff on these things. So if you put it to 96%, it won't turn on, okay? But if you put it to 95%, it won't turn on. 94, I don't remember that. Yeah, 94% is the turn on. So 94% is our maximum, right? So 90 to 94% equated to no more amperage draw, no more airflow. So we'll just use 90% as a maximum. I'm gonna run them back down to 20%. And now we're gonna turn fan 1 onto 90% as our maximum, then I'm gonna turn fan 2 on. So there's 90%, which is our maximum speed for fan 1. I'm gonna go over here to fan 2, the same PWM table that we were just working with. I'm gonna run that one up to 90%, and you're probably not gonna be able to hear me anymore. So what you can do with that PWM table is scale it so that it slowly works its way up to 100%, which in this scenario, I don't think that these fans, not 100%, 90%, which is 100% airflow. Which in this scenario with 2 of these things, I don't think we're ever going to actually see that. I don't think we're ever going to need to actually run these fans wide open at all. And if we do, it's going to be very, very briefly. So I just put out a video that I made about a week and a half ago, but we just put it out today, earlier today. It was on a battery and alternator, and one of the questions I got was, well, what's the reason for having 140 amps at idle? Those fans at wide open draw 42 amp, 43 amp, right? So that's just 2 fans, and the water pump draws 12 amps, right? So now we're up to 56 amps. If we want a cushion, 140 amp at idle is more than a cushion, more than enough of a cushion to run the rest of the car, like a fuel pump and like the trans-cooler fan and all that kind of stuff. So injectors, coils, yada, yada. So yeah, I think that this was a great success. The fans were a very good idea, and Justin, the guy who works with us, it was his idea to do the Silverado fans. Yes, he was right, they won. So we did a 14 fan shootout and these won. So yes, he was right. But anyway, that's how you set up PWM fans from GM. I believe the 16 Camaros are the same, 16 and up Camaros. Pretty sure the, there's another fan from the Chevrolet, newer, Corvette. Or maybe the 17 Corvettes or something like that also use the same setup. So if you dig around, you'll find some GM fans that do it. And the Chevy Volts, 11 through 16 Chevy Volts. So there we go. That's all we got. That's how you